Right. So, people, now when it comes to the logic gates, here we are trying to get to know how the circuits, or like circuits kiwamat, the smallest component of a circuit is going to work. Now we can consider gates as the smallest unit, not as the smallest unit, like a small component of a circuit, right? And since this computer is dealing with ones and zeros, the gate is the one, the gate is the component which helps to create those logics, like api process karanna dunnama, like what to be done to this particular data that is receiving, because you know the data will be received as ones and zeros. Later those data should be processed, then that processed data, the output of that should be in like interpreted means like should show to us, right? So the input will be taken as ones and zeros. Gates are helping to convert that input, the keyboard inputs, the mouse inputs, the touch inputs that we are giving into ones and zeros. And again, it is helping the all these circuits and all these things to process it. And again, it helps us to produce an output when it is needed for us, like to show it on the monitor or to have it on the printer, right? Kind of things, right? So basically, these gates are dealing with the electricity, right? So gates can have inputs, right? We are going to learn what are the inputs called, right? So gates, we are going to have inputs as well as outputs. So for inputs for the gates will be considered or will be taken with the electricity, right? So the flow of an electricity, it is called or it is indicated one, and not flowing an electricity is indicating a zero. Api number system pada patan gannakota we talk about this, why what is represented by one and which is represented by zero, right? So inside the inside this area, right, inside this area, we got these two type of gates called basic gates and the combinational gates, right? So we'll build up a little short note regarding this in your book as well, even though you are having the tute. And again, we have a lot of activities to get done through this. So be prepared with a book and a pen as well, right? So now in the first 3-4 pages, it is discussing about these basic gates and the combinational gates, right? So I'll illustrate it to you like this. Just a second, people. We need to see how the previous things have gone with this. Oh, okay. Let me clear this. Right. Then I stay for a minute. It will take a little time to clear the board. Yeah, great. So the fourth unit, These gates, as I told you, are divided into two major parts, which is called basic gates and the other one is called the combinational gates. All right. So basic gates has four different types, which we call NOT, and, O, and XOR. And combinational gates, there are three, which we call NO, NAND, and XNOR. Right? I think you are familiar with the basic gates. We talk about these words in the number system lesson as well as bitwise operators, right? And in the combinational gates, this NO and NAND is given a special name called universal gates, right? Okay, so it's better you write this down as a start of the gates, right? Body summary එකක්, right? Then we'll summarize the basic and the combinational gates, right? Start it, people. So please get it done. Okay, one is done. How about others? All right. Okay, so moving forward. Now here we are going to discuss about the basic gates. right? So in basic gates, so there are 4 types, you know, right? So the first type is not. Now there is a symbol for not gate. This is the symbol of the not gate, right? And this end is called the input line, and this is the output line. Right, and it is common for everything. There will be input line or lines, there will be output line, right? And always remember there is only one output line according to our syllabus, right? When it comes to the advanced part, we can see like different kinds of outputs from a gate, but what we are learning is like there can be only one output line for any gate. And for not gate specifically, there is only one input line. It cannot have more than that, just one input line, right? So input line and output line is there. And again, we represent what happens when certain input is given to this input line and how it is going to represent as the output. So if we say when A is given, the output is taken as A bar or A dash, right? So A is the input, so it becomes A bar or A dash when it comes to the output. Now this is nothing that you know how the NOT gate is going to work, right? When we are like doing the bitwise operation, we talk about the NOT, how the NOT operator works. Now here, the same operator represented in the gates, right? So this is what happens to the inputs and outputs of the NOT gate, right? So we draw this table when we are referring to gates, which we call the truth table, right? And we represent the inputs. I told you the inputs that a gate can take, it can happen in zeros or ones, right? So when a 0 is given as an input, output will be 1. And when a 1 is given, the output will be 0, right? That is how a particular NOT gate is going to behave, right? So this component, this table, is called the truth table. And it is there in your note, right? But it's better you summarize this as well, right? I'll tell you when to be done, right? And the second gate that we are going to talk is the AND. Now, AND gate the shape of the AND is like a capital D, right? It has minimum 2 inputs. Can we have the inputs greater than that, 2 or more, right? And the output comes as one single line, right? And the operation through the AND gate, we define it as a Boolean multiplication. We represent it like this, A dot B. And this dot, this particular dot indicate Boolean multiplication. And Boolean multiplication, why we use the word Boolean, this area which we referring to the gates, we refer it with Boolean algebra, which describes how ones and zero works with each other, right? So because of that, we tell this is a Boolean multiplication, which is almost similar as the normal multiplication. Later, you will find in the OR gate, there is something called Boolean addition. It is again almost similar, but there is a one major difference when it comes to the Boolean addition. I'll tell you what happens there, right? And if we think about the truth table of the AND gate, we have A and B as the input. So our output is going to be A dot B, right? So how we are going to represent this is like when A is having 0, B can have a 0. A is having 0, B can have a 1. When A is having 1, B can have a 0. And A is having 1, B can have a 1. Right? There is a certain way of writing this. I'll tell you when the time comes, right? So for the moment, let's go with this. And here, the output represents the multiplication, right? So these two are inputs. And this is the output, right? So what's happened here? Like 0 into 0 gives you 0, 0 into 1 gives you 0, 1 into 0 is going to give you 0, 1 into 1 is going to give you 1, right? So it is same as multiplication, right? But there are differences, but we are not describing it within our syllabus. So it's something beyond, right? And this is about like how an AND gate behaves, right? So the third one, is named as the OR gate, right? OR gate, right? Now OR gate, we can draw it like this, right? Some are drawing it like this as well, but I prefer neither. Crescent එකක් වගේ අඳින්න පුළුවන් නේද? හඳ පළුවක් වගේ. It's better, right? And it has two inputs and also can have more, right? And can have one output. And when we give A and B to this particular gate, this outputs A dot B as its output. So it is called Boolean. I'm sorry, my bad. It's not the dot, it's the plus. A plus B, right? And this is called Boolean addition, right? So for the OR gate, again, we can have the inputs like A and B, and the output is going to be A plus B. So we know the patterns 0, 0, 0, 1, 1, 0, 1, 1, and the output is going to be, I told you it is almost similar to the addition. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is going to give you 1, still not 2, right? And I'll tell you why this 1 plus 1 is going to be 1, because here in the with the Boolean algebra, we represent 1 as true and 0 as false, right? So when it comes to the 1 plus 1, that gives you a true is added to a true, which gives you a true again. And if you think it on the physical level, right, or like the very practical scenario, it's going to be the current or the electricity, right? So when electricity meets another electricity, it's not going to like multiply or like add up the things. It's going to produce you the same level of electricity, right? Electrons එකතුවක් නේ සිද්ධ වෙන්නේ. You don't need to think about it, right? Just remember, in the Boolean algebra or regarding the gates, 1 plus 1 is 1, not 2, right? So it is the way that the A and B inputs are going to work, right? And the very last basic gate is called XOR, which we say exclusive OR, right? XOR stands for exclusive OR, right? And since it is kind of a OR, the shape is also something similar to OR. Now we know OR refers like this, and since it is exclusive, it has an extra line before that, right? Like this. And the inputs will be connected to that. Oh, that is ugly. And remember, this XOR is specially designed only for 2 inputs, right? I'll write it over here. Specially designed only for 2 inputs, right? And how we are going to represent this, we say when A and B provides over here, this gives us A exclusive plus B. Exclusive O එක අපි indicate කරන්නේ ඔය විදියට plus එකක් දාලා වටේ රවුමක් හදන්න, right? And truth table, right? It is a little bit special. A XOR B. The specialty is like we got the same combinations. Now, when the inputs are identical, that means when A and B got 0 and A and B got, both A and B got 1, then the inputs are identical. When the inputs are identical, this produces a 0. And when the inputs are not identical, it is producing 1. That you have to remember, right? When inputs are identical, it's producing the zeros. When they are not, it produces 1. Okay, people, is it clear? These are some basic stuff regarding the gates, right? Shall we start writing this? This will be a good short note for you. So these are there in your tune, but it's better you summarize this up, right? So please take it into your notes.
So exclusive O කියන එකට මේ diagram එක ගන්නද?
Diagram එකක් කිව්වේ මේ
ඒ කියන්නේ දැන් හරි සර්.
ඇඳලා තියෙන පුතේ.
හරි සර්.
Right? හරි. අපි ලියාගමුද? Right, great. වජිර පොඩ්ඩක් ලේට් වෙලා නේද පුතේ ආවේ. අපි මේ ටික කතා බහ කරගෙන ගියේ. මෙතන මේ උඩ පොඩි දේවල් ටිකක් ලිව්වා. ඒකට චුට්ටක් ඉඩ තියාගන්න. තියාගෙන මෙතනට යන්න. right උඩ ටික ලියන්න පොඩි පිටු භාගයක් වගේ. Let me know when you are done, people. I need to scroll it to your right. Right, I'm moving it a little bit rightwards. Yeah, I'm moving the screen, people. If you miss anything, just let me know.
එක්ස්කලසිව් ඕ කියන ගේට් එකේ මේ එක පාට ගැන එකම සිම්බල් එක තිබ්බොත් 0 නේද වැටෙන්නේ?
ඔව් ඔව්.
කියන්නේ
ඒ කියන්නේ
zeros
inputs
දෙකක් හරි ones
දෙකම
දෙකක් හරි.
inputs දෙකම ඔව් සමාන වුණොත් identical වුණොත් බිඳුව
හරි.
වෙනස් වුණොත් 1. Right. Okay. Is everyone done? Right. So let's move to get to know about the combinational gates. Now, we get to know about the basic gates. So now when it comes to the combinational gates made out of the basic gates, right? So that is why it is given the name combinational. It's combining two gates to have the one particular combinational gates, right? So it is like, now if I illustrate, combinational gates. So the first one is called, let's say Nand. So you can see like there is an N in front of the AND, right? So the same happens over here. So the circuit is created like this. We take AND gate and we connect a NOT gate to the output of the AND gate, right? So we know when A and B is given, this gives you A dot B, and definitely this is going to give you A dot B total bar, or else we can say A dot B total dash, right? And we are not drawing the circuit symbol like this. Instead of this, we are drawing the NAND gate symbol in this particular way, right? So we say A and B is given, A dot B bar is given as the output, right? And before I draw the truth table here, I want you to take your concentration to the truth tables of the AND and O. Now, if you look closely, you can see like in the AND gate, you should have ones to both the inputs to have an output as a 1 in AND gate. Like in case if any input receives a 0, output will be definitely going to be a 0 in AND gate. The opposite happens with the O. Like when both the inputs are 0, then only O is going to output a 0. In all other cases, that means at least a one particular input indicates a 1, it's going to output a 1, right? So it is something that we need to remember. ඔක ගොඩක් වෙලාවට නේද එහා පැත්තට මෙහා පැත්තට දාන්න නොකිය ඔයගොල්ලන්ගෙන් අහනවා, right? So you have to remember that pattern. Now when it comes to the NAND gate, you will see the output of this AND gate is going to implement or invert, right? So we can draw the NAND gate's truth table like this. Right, so the output means to generate the output, we have to multiply and invert. So 0 into 0 is 0. Once it is inverted, it's 1. 0 into 1 is 0. Once it is inverted, it is 1. 1 into 0 is 0. When it is inverted, it is 1. 1 into 1 is 1. Once it is inverted, it is 0. Right? So this is how the NAND gates work. So in a very same way, no is being made, right? So what happens here, now you can either clear the picture. You get an OR gate, you fix a NOT gate in front of it, so it's going to give you no. So this means A and B is input. This is going to give you A plus B. So here you are going to receive A plus B total bar or A plus B total dash. And people remember, like when you are doing the operation, it's better you use to these brackets. Right? So the very same way we illustrate the NAND, we can illustrate the no as well. So how we are going to illustrate this? We put the small dot in front of the OR gate and we represent the no. So A, B is here, A plus B total bar is going to be here, right? And if you consider about the truth table, now why I am drawing this truth table and asking you to draw it again, sometimes they will give you a particular truth table and will ask what is the related gate regarding this. So you better have the idea, right? Which gate is getting which truth table, right? So this means add up and invert. 0 plus 0 is 0. Once it is inverted, it is 1. 0 plus 1 is 1. Inverted gets 0. 1 plus 0 is 1. Inverted gets 0. 1 plus 1 is 1. Inverted, it will get a 0. Similarly, now you know what happens with the XNOR, right? So, and remember, lamai XOR එකේ ඉස්සරහට no එක not එක දැම්මම n XOR නෙවෙයි හැදෙන්නේ XNOR කියන එක හැදෙන්නේ, right? Right, so remember that. ඔගොල්ලෝ පටල ගන්න තැන්. So what we are doing is in XNOR gets an XOR and we fix a NOT gate in front of it. So then AB, once AB is given, this is going to give you A XOR B. So this is going to give you A XOR B complement or A XOR B dash, right? So it makes what? This particular gate. Then XOR එක අඳින්න කිව්වොත්, combinational අඳින්න කිව්වොත්, you are going to draw the second symbol, right? Don't draw the first symbol. It is to clarify how things happen, right? So this is A XOR B total bar. So if you think about the truth table, we got A, we got B, we got A XOR B complement. So it's going to be 0, 0, 0, 1, 1, 0, 1, 1. So 0, like the logic that we use in the XOR when the inputs are identical. Inputs ටික එක වගේ වුණොත් එයා output කරන්නේ 0 XOR එකේදී. Once the inputs are differ from each other, it gives you 1. So here it goes the other way around. If inputs are identical, it's going to give you a 1. මොකද 0 output කරාම not එකෙන් එයාව අනිත් පැත්ත හරවනවා. When inputs are different, you are going to receive a 0. හරි. තේරුණාද? Confirm, please. Right. Great. So let's take this down quickly, people. So the combinational gates. I'll scroll when you're done, right? Right, so moving upwards. Right. So I'm moving a little bit up. If you are missing anything, let me know, right? All right, one is done. How about others? Right. So let's move forward. Lamai, give me a second. Right. Okay, so that's the description of your tube, right? If you are finding the words like Saleo, Kumbalavo, Karavala, like it's not me, right? It's from the fish lorry, right? Yeah, our next topic is creating truth tables for given expression, right? Now, yeah, when you are creating a truth table for a given expression, you have some way to do that, right? Like you solving a particular math according to the mathematical operator prioritization, right? So like if you are given to solve like 2 plus 3 divided by 6 multiplied by 2, so there is a way that you are going to do that, right? Like as an example, if someone says to solve you like this, 2 plus 10 divided by 2 minus 3 into 5, like there is a way we do this. First we solve the divisions and multiplications, right? So later we will think about the additions and the subtractions, right? So likewise, when we are asked to draw a truth table, now we will be finding the operators in the Boolean algebraic area, right? So like like you will be find the plus, you will be find the dot, you will be find the dash or the bar, or you will be find the XOR, right? Kind of operators will be there. So as you got the prioritizations for the mathematical operators, similarly, you will be having the priorities for the Boolean algebraic operators as well, right? So that is what I'm sorry, this particular table shows to you, right? And when we are given a particular expression, I'll show you what is the expression. And first we are going to solve, or like when we are going to represent the complements in that particular expression. Then we are going to represent the ands, then we are going to represent the O's, finally we are going to represent the XOR. Right, so later you will realize XOR can be written as a combination of multiplications and the additions as well, right? And again, now when you are creating a truth table, right, in short form we call it TT, right, which is not standard for table tennis in Boolean algebra, right? But when you are creating a truth table, you are going to determine how big the truth table is. Now let's concentrate on the truth tables that we have drawn so far. Now look at the NOT gate truth table. It has two data rows, like two rows which contains ones and zeros. And if you consider about the other truth tables that we draw, it has four rows. Now these rows are determined by the input combinations. Right now, if you think about the NOT gate, it has two type of combinations, either 0 or 1. And if you consider about the AND gate, it has four type of combinations since we got two variables. So both A and B can have 0. Once A is having 0, B can have 1. Once A is having 1, B can have 0, or both can have 1s. So the lengthiness or the height or the size of the truth table is determined by the number of combinations which are about to create by the inputs. So once you are given an expression, the very first thing that you need to do is determine the number of inputs in that expression. Then you are going to determine how big your truth table is going to be. Then according to the priorities for the operators, we are going to build the particular truth table, right? Okay, so let me illustrate it to you how these things are going to happen, right? What was the example that I took? Okay, yeah, I'll take something much simpler for you guys, right? Because XOR is not very much into the calculations, right? Or to the representations, right? So I'm going to build a truth table for a given expression, right? So building a truth table for a given expression, right? So as an example, I'm going to take this A plus B dot Z B dot C bar, it is within the brackets, right? I put these brackets because I need you to take your concentration for brackets as well, right? Okay, now if you consider about this expression, how you are going to determine the number of inputs, right? So you can determine the number of inputs by searching how many number of different letters are there in the expression. And remember, when you are counting the different number of letters or in the inputs, do not bother about the operator, right? That means, I know you are not going to bother about the pluses and dots, but some of you are bothering about when it is containing a bar or a dash. So you are struggling. Is A bar and A are going to be considered as one particular thing or two particular thing, right? So hear me out very clearly. It is just a one particular thing. We are just counting how many different letters are there in the expression. That's all. So according to this expression, how many different letters are there? There are 3, right? So it is very easy to recognize, right? So the first task then, determine number of inputs, right? So in this case, 3 inputs are available. And people, you don't need to write this write like this when you are solving or when you are asked to draw the truth table. You only need to draw the truth table. I'm just showing you how it happens, right? And then the second thing is you are going to determine how big your truth table is. Right now, when it comes to the note, let's say we are going to determine the number of rows in the truth table, right? So determine number of rows in the truth table. TT is given for truth table, right? So for this, there is a small equation, right? And you can remember it like without using the equation, you can just remember if one variable is 2 line, 2 variables are 4 line, 3 variables are 8 lines, 4 variables are 16 lines. That's all that you are going to refer, right? But I'll show you what is the relationship is, right? So we can determine this by this particular equation. Number of rows in a truth table equals 2 to the power number of inputs, right? So in this case, how many? We got 2 to the power 3, which means 8 rows will be there. So for those 8 rows, there will be 8 different combinations, right? Then the third thing that we need to do is draw a one particular column per one particular input and fill out the combinations, right? So start constructing the TT and fill up the possible combinations, possible input combinations. දැන් මම මේක ලියනකොට මේ පියවර ගොඩක් කියලා පෙවුනට this is just a 2 minutes work, right? I'm writing this in detail for you to have the idea, since you are hearing this for the very first time, if you are hearing this for the very first time, right? And yeah, so I got to know there are 3 inputs, and I got to know there should be 8 rows, right? So I draw A, B, and C, a column for each and every input, and we are going to fill out the columns. Now, how we are going to write the combinations? Now, there is a logic behind this, and there is a way that you can have it within a second, just disregarding the logic, right? Shortcut එකක් තියෙනවා, කට්ට ක්‍රමයක් තියෙනවා මේක වැඩේ කරන්න, and there is a logic behind it as well, right? So මුලින්ම මම කියලා දෙන්න shortcut එක මොකක්ද කියලා, right? So we determine there are 8 number of rows, right? So I'm drawing those 8. Right. So what I'm going to do is I'm going to fill my first row by ones and zeros. The pattern that I'm going to fill is first 4 columns will be, first 4 rows will be zeros, and next 4 rows will be ones, right? So generally what did I do? We got 8 combination, so we had half number of cells in zeros and the other half from the ones, right? Then when I'm going to fill the second column, I consider the identical part of the first column, and again the same practice, half of it filled from zeros, half of it filled from ones. For the rest of the half, happen the same thing. Half of the ones filled from zeros, half of it fills from ones. People, is it clear what I'm doing? Right. How about others? Right, okay. Yeah, Sachintani and Nirmana.
Clear, sir.
Right. Okay. So when we are going to fill out the third column, we are going to do the very same thing again. We are referring to the previous column. Identical rows will be taken, half of it from zeros, half of it from ones, right? And again, there are 2 ones in the B column, half of it from zeros, half of it from ones. So it's going to be like this, right? Now we are done. So this is the shorter way, right? The 16 inputs are what? 16 combinations are what? First column එක කොහොමද fill වෙන්නේ? First 8 from zeros, next 8 from ones. මොකද inputs 4ක් આવොත් you are going to have 16 combinations. So the first 8 filled from zeros in the first column, next 8 is going to fill from ones. When it goes to the second column, first 4 is zeros, next 4 is ones, and again the next 4 is zeros, and next 4 is ones. Right? Likewise, you can maintain this truth table, and there is no rule that you have to write this combination in this order. අපි මෙහෙම ලියන්නේ අපේ වැඩේ ලේසි කරගන්න. මේ combinations අට කැමැති විදිහකට මෙතන තියෙන්න පුළුවන්. But it should be 8, there should be 8 combinations somehow. Right? So now what is the logic of filling these things up? Right? මේක මේ කෙටි ක්‍රමයේ වුණාට මේක ඇත්තටම වෙන්නේ we are referring into a truth table which represent the binary values in 3 bits. So these binary values will have the place values like 1 to 4. Right? So since we got 8 rows in our truth table, we name it like 0, 1, 2, 3, 4, 5, 6, and 7. Right? So these are the binary representation of these decimal numbers. Got that? If you think about the binary numbers, you will realize, okay, 0 is written 3 zeros. If you take 5, 4, and the 1 will be taken. So 1, 0, 1 can be written. Likewise, you will realize this is how it happens. Right? So that is the logic behind this, but we are not very much into logic since we are like fighting with the time when we are doing the examination. So we go with this pattern. Right? Now you are halfway through. So the next half is with the operators. Right? Now then the only thing that you need to do is complete the truth table by considering operator priorities considering operator priorities. Yeah, operator priorities කියලා කොහොමද නේද? It's better I say Boolean operator priorities. Right, complete the truth table by considering Boolean operator priorities. So priorities goes like this. So the brackets got the highest priority, then the not, right, or the dash, then the dot, finally the plus. Got this, people? So these are the operator priorities. Now we are going to complete this truth table.
So priorities truth table එකත් එක්ක සම්බන්ධ වෙන්න කොහොමද?
Oh, ඉන්න. අපිට මේ අඳින්න හදන්න බෑ.
ඒකස අපි සර්කිට් එක දුන්නාම මේක බලන්නේ අපි truth table එක අඳින්න.
එහෙමත් පුළුවන්. නැත්නම් එක්ස්ප්‍රෙෂන් එක විතරක් දුන්නම අපිට ගන්නත් පුළුවන්. දැන් මම මේක ගත්ත උදාහරණේ මම අරගත්ත එක්ස්ප්‍රෙෂන් එක විතරනේ නිර්මාණ.
එතකොට ගේට් එක ඇඳලානේ අපි table එක ගන්න.
අඳින්න ඕනේ නැහැ. අවශ්‍ය නැහැ. සර්කිට් එක අඳින්න අවශ්‍ය නැහැ. ඔයාට එක්ස්ප්‍රෙෂන් එක දීලා truth table එක අඳින්න කිව්වොත් truth table එක විතරක් ඇඳෙම ඇති. ඔයාලට සමහර වෙලාවට කෙලින්ම සර්කිට් එක දීලා ඒකෙන් එක්ස්ප්‍රෙෂන් එක අරගන්න කියලා then after you ask to draw the truth table. අන්න එහෙම වුණොත් ඔයා සර්කිට් එකෙන් එක්ස්ප්‍රෙෂන් එක අරගෙන ඒකට දාලා truth table එක අඳින්න ඕනේ. Right? So this is the, oh my god, why is that? Didn't I copy it? Okay, let me do it again. Okay. ඉරටි කැවිලනේ කමන්නේ ඉරටි කපිලා right. So my expression is what? A plus b dot c bar, right? I'm going to take it over here. Right. Now we are going to consider the priorities. So how my columns are going to be. Now, if I think about the expression, there are all four operators are there. Brackets are there, dots are there, bars are there, and pluses are there. So the first thing, and these got the priorities. It's better you name the number of like the rank of the priorities. So first we are going to consider about the brackets because it has the top priorities, right? So when you take a bracket, you should go into the bracket, inside the bracket. So when you go inside the bracket, you can find two types of operators. What are those? The multiplication operator, which is the and the not operator, right? So from this list, not operator takes the first priority. So because of that, you can create a z bar column. So how we are going to create a z bar? So you got the c column by looking at it, just invert the bits. So c is at its right left. So this 0 becomes 1, 1 becomes zeros. Right? So I'm inverting the bits of the C column. People, do you get this onto this point? Up until to this point. Is it clear? Right, brilliant. And then what we are going to do is, now not operator is done. So now I am going to create the dot operator. Now dot operator is in between B and C bar. Your B column is right over here, C bar is right over here. So considering those two, B dot C bar will be created. So that means multiplications. So 0 into 1 gives you 0. 0 into 0 gives you a 0. 1 into 1 gives you 1. 1 into zeros. Here you got 1, here you got zeros. So you're going to 0. And 0 into 1, again 0. 0 into 0, again 0. 1 into 1. And 1 into 0 is going to be a 0. Right? So 0, 0, 1, 0, 0, 0, 1, 0. Yes. It's better you always recheck, people, since we are working with lots of ones and zeros. There is a huge room to make a mistake. So b dot c bar is done. That means the bracket is done. So now you come out of the bracket. Now you got a plus operator with a. So a is there. Plus operator is doing a and this particular output b dot c bar, right? So sometimes these expressions will be given like f equals kind of a thing. Then I can mark the output as f, but this time I'm going to mark it as the expression says, like a plus b dot c bar, right? So I am considering the columns which has red dot above, right? May red dot එක දාලා තියෙන තැන් දෙන තමයි අපි consider කරන්නේ, right? So what's going to be the answer? Those two are going to add. So if you have 0 in both the places, that's going to be a problem, right? So let's see 0 and 0. It's not going to be a problem actually. 0 plus 0 will give you a 0. 0 plus 0 again will give you a 0. 0 plus 1 give you 1. 0 plus 0 is 0. 1 and 1 plus 0 is 1. 1 plus 0 again 1. 1 plus 1, we know it is again 1. And 1 plus 0 is also going to be 1. Let me check it again. So it's 1, 1, 1, 1, 0, 1, 0, 0. Yes, yes. So my truth table is completed. තේරුණාද? If you got any question, let me know. Okay, let's take this down, people. This is how we are going to create a truth table for a given expression. There you go. I will correlate when the time comes, right? Let me know if you are done before that. Now I continue writing. I'll be right back. Lamai, let me know if you miss anything. I'll keep the those two statements like that, so you can complete the truth table and come to the latter part and do the completion, right? I'll scroll it a little bit, little by little, towards the up, right? Let me know when you are done, people. All right, it seems everyone is done. So let's do some truth tabling, people, right? So I'm giving you a very simple one. So you can send me the answer, like you can take a photo and send it to the WhatsApp, right? So here comes the first question, right? Now, that's my little one, right? Don't worry, there is no any monsters around me. Right, so this is going to be A bar plus B bar dot C. Right, okay, give it a try. Always remember the priorities, right? hold on. Right, yeah, I have received yours. First one, it is Lalindis. Yes, let me see, okay, right, okay, yes, yeah, Biba is correct, Biba dot C is correct, yes, Eba is correct, and addition, that's correct, well done, Lalindi, that's correct, and Likini, yes, yeah, your output is correct, well done, and Nirmana, let me see, yes, that is correct, Nirmana, well done, and for the people who have done it, here comes the second one. Right, keep doing, people, and when you're done, let me have the photos, right? Pahanmi, I received yours. Let me see, Dua. Dua, there is a problem. Hold on. In about it. Okay, the column A is right, B is correct, C is correct, and A bar is correct. Yeah, like yeah. You took the B bar, right? Yes, B bar. It is correct, and B bar dot C. B bar dot C column. B bar dot C කියන එක තමයි දුව වරද්දගෙන තියෙන්නේ. Just go through the B bar dot C දුව. It is just multiplication of the B bar column and the C column දුව. මට හිතෙන්නේ දුව එක add කරලා කියලායි මට හිතෙන්නේ. බලන්න. Yeah. Oh, දුව මම දැන් වෙන column එකක් consider කරලා තියෙන්නේ. ඒකයි උත්තරේ වැරදිලා තියෙන්නේ දුව. Look at the B bar and the C, right? Others are okay. So B bar dot C හැදුවම output එකත් වෙනස් වෙනවා ඒකට ගැලපෙන විදිහට. Right, Nirmana. I received the second one. Let me see. ABC is correct. B bar is okay. C bar is okay. A dot B bar.
Very good.
Yes. A dot B bar is correct. Hold on. A dot B bar.
Right, C.
Yeah. A dot B bar is correct. B dot C bar. Yes. B dot C bar is correct as well. Well done. So the last output, yes. Yes, that is correct. Very good. Very good, Nirmana. That is correct. Go for the third one. Yeah, පහන් මිදුව first එකේ පොඩි ගැටලුවක් තියෙනවා. මිනිඳු බලන්න. පහන් මිදුව like it's better you write ABC මුලින්ම එක ළඟ ලියා ගන්න දුව. ඒ ලියාගෙන යන සමහරට ඒ නිසා වෙන්න පුළුවන් ඔයාලට පොඩ්ඩක් පැටලලා තියෙන්නේ. So A bar is okay anyway, B bar is okay. But it's better you write ABC first, then go to the A bar and B bar, right? And
It's going to get bluer.
B bar dot C. Yes, okay. Right, okay. So A bar plus B dot C.
Mom, it's getting blue. Look, Mommy.
Okay.
Mommy.
How many do I? අනිත් අයගේ ටිකත් එක්ක මට පොඩ්ඩක් compare කරලා බලන්න. Maybe you are right.
Is it getting blue? Yes, it is. Look. Yes, it is. Look, everyone. The dress is going blue.
Yeah, කොතනක හරි අවුලක් තියෙනවා. මට ඔළුවට එන්නේ.
So pretty.
Suhara, lower your sound please.
I am sorry. Mommy, can you sit down? Sit down, Mommy.
Right, okay. හරි දුව. වැරද්ද තියෙන්නේ ඒක වැරද්දක් නෙවෙයි. ඒක වැරද්දක් නෙවෙයි. කියන්නේ දුවාර combinations ලියාගෙන තියෙන එකේ එක මාරු කරලා ලියාගෙන තියෙන C එක ලියලා තියෙන්නේ 1010 කියලා. 0101 නෙවෙයි 1010 කියලා. So according to that your output is correct දුව. අපි අර ABC ලියපු pattern එකට ලියන්න බලන්න දුව. ඒක ලිව්වම කියන්නේ මට access කරන්න ලේසි ඔයාව. මොකද අනිත් හැමෝම මේ විදිහට කරලා එවන්නේ. So I can clearly Suhara.
Suhara, can you go inside?
No.
Then shut up.
Right. Pahanmi, your first answer is okay, Dua. Go for the second and third and follow the instructions. Instruction means like the way we did it, right? And Nirmana, third one. Nirmana, තුන්වෙනි එක නම් වරද්දගෙන තියෙනවා. තුන්වෙනි එකේ වැරද්ද මොකක්ද දන්නවද? Third expression එකේ පුතා තියෙන්නේ variables දෙකයි A and B විතරයි. එතකොට අපි combinations 8ක් ගන්න ඕනේ නැහැ. Right? බලන්න ආයි කරලා වන්න. Nikini, PC. Okay. The second one, hold on. Let me defer the Nirmana's answer for the second one. 0010111. Yes, Nikini, the second one is correct. And the third one, Nikini, hold on. Okay. Yes, correct, Dua. Third one is correct as well. Okay, so people who have done the first these three questions, yeah, you can exit today, right? I'm going to end the session from like just by seeing these things. So Nikini, since you have sent me all three truth tables, you can go, right? You can leave. Have a nice day, Dua. Right? I'll see you on next Saturday for the same time. Others, you have to send me the answer and wait until I confirm. And Pahan me, Anna Haridu, right? Hari. First take Haridu then. Very good. Send me the other two Dua. Lalindi, Kabaramu. Lalindi, second එක පොඩ්ඩක් ගැස්සිලා තියෙනවා. Third එක okay. Second එකේ කොහෙද වැරදිලා තියෙන්නේ කොහොමද? Lalindi, go through the B dot C bar column. It is the place where you have went wrong. Right? So according to that, second one is going, the output column is going to be a problem.
What do you want? Tell me,
Right?
what do you want?
Correct it and send it to me.
Oh no, I need to send you.
Nirmana Kobalan Anna Hari. Yes.
That's why you're going inside.
Hari Hari Nirmana, ඒක තමයි උත්තරේ. Right? Hari. Nirmana exit vendor.
Thank you, sir.
Right, okay. Right, okay. And this is Pahanmi the name. Sachintani. Sachintani, let me see. Right. Sachintani duwa podi ගැටලුවක් තියෙනවා කො බලමු. A column is okay, B is okay, C is okay, B bar is okay, C bar is okay. A dot B bar, let me see, A dot B bar is okay. Okay, right. A dot B bar column එක තමයි දුව වරද්දගෙන තියෙන්නේ. Sachintani, A dot B bar column එක පොඩ්ඩක් හරියට go through කරලා බලන්න. Right? A dot B bar column එක. Lalindi. Yes, Lalindi, that is the correct answer. Well done, Dua. You can leave. Have a nice day, Dua. Thank you very much. Right, okay.